On the Flip Side with Debra Vogler.
Hi, I'm Debra Vogler. Welcome to Chip Scale Reviews on the Flip Side, your chance to hear from semiconductor industry's top experts. My guest today is Ghannam, CEO and founder of 3DIS Technologies. Welcome, Ayad.
Hi, Debra. Thank you.
Your technology portfolio is based on a peripheral 3D interconnect process and includes 3D integrated passive devices, 3D interconnects, 3D redistribution layers, and wafer-level 3D packaging. Could you go into a little detail about how you were able to make wafer-level 3D packaging cost-effective while still meeting performance requirements?
We actually developed a what we call conformal 3D redistribution layer, or 3D interconnect layer technology, which allows us, in fact, to form copper at the same time, both in vertical and horizontal surfaces. So this is the main core of our technology, and we can do it also with high resolution. It means that we are capable of achieving line space, for example, of 15 micron by 15 micron width on a vertical height of around 150 micron. And we could even reach a very higher vertical heights. So this is the core technology, and around it we developed solutions, so wafer-level packaging solutions and 3D integrated passive devices. In fact, what happens is that since we can lay out this technology conformally, we allow then ourselves to integrate 3D packages, or I will say it, to stack dies in a 3D way, and to perform interconnection between these dies and their PCB or substrate, or for other solutions such as substrateless, using one single electroplating step. So it means that if we take regular, for example, 2.5D, where you need to have a flip chip to prepare a wafer, for example, with TSVs or other type of interconnects, so too many processing steps, so higher cost. In our case, we only need 1 to 2 lithography masks, electroplating step, and we are capable of forming at least these interconnects. So in addition to that 3D technology, we are capable also of forming what we call through package vias. So the through package vias are interconnects that allow to form electrical connectivity between two sides of the package, its top part and bottom part. So that means that we are capable of doing RDL on both sides of the package, which means that, for example, for 5G application, that could be beneficial to forming the IOs of the package on the bottom, and then to do RDL build up to form the antenna on top of the package. So we call it antenna in package application. So the fact also that we can form these through package vias, we call them like that, using the same electroplating step or processing step as the 3D RDL, makes this technology even more cost effective for such applications.
Your 3D RDL technology can be used independent of the number of stacked dies and their thicknesses. Could you describe the challenges that had to be overcome to develop it and how it enables next generation 5G applications?
Indeed, we had too many challenges to address before this technology met fruition. First, we actually had to find a way to form these high-density vertical interconnects or conformal interconnects that require, in fact, us to take a commercial photoresist and modify it in a way that could allow us to form very high thicknesses and also high aspect ratio interconnects. So that means that we had to tune a lot of processing steps, such, for example, as the bake, the exposure, and the development of this photoresist to create the openings on all these multi-height, we call them, interconnects. So it was very hard to achieve, but yeah, we succeeded in doing that, and that constitutes the core know-how and IP of our technology. Then we had also to develop a new and improved copper electrode deposition chemistry, because what we do is we electroplate copper both on vertical and horizontal surfaces. So we needed that copper to be, the thickness of this copper to be very conformal on all these faces. And we definitely also needed the copper to have very low surface, because for RF application, for example 5G, you need to have very low surface of metal to reduce the RF losses in the interconnects. So once that was sorted out, we also had to develop custom etching solutions, such for example for the seed layer, in order for us to keep the copper density very low, the copper roughness very low. After etching the seed layer, we had also to find and work on what we call repassivation dielectric layers, because we needed materials that could be laid on in a 3D on 3D topology, and that could also allow us to perform patterning of this material using one single lithography step. And lastly, a lot of work was performed on materials, mainly to address reliability issues, for example, to compensate for a difference in CTE mismatch between, for example, the package and the die. So how we can enable next-gen 5G? We actually allow ourselves with this technology to integrate directly 3D stack dies inside the package. And then we use these through package vias that are formed at the same time with the 3D interconnects to create interconnection between top side and back side of the package, and then to perform build up on the top of the package, for example, to integrate the antenna or other type of devices on the package.
Your company has quite a number of partners. Could you describe one or two of your collaborations and some of the milestones or accomplishments that have been reached?
Yes, we currently are working with partners from different industries and application, like, for example, aerospace industry, also in terms of automotive, for example, for the radar application, and a lot more effort recently also on 5G applications. We unfortunately cannot cite a lot of these clients, but I will state, for example, for the aerospace that we work with Thales and Space for next generation component in the satellites. And we work also, for example, with NXP and on 5G applications. So for these clients, on some projects, we have reached very high TRL levels. So it means that products underwent reliability qualification, and some of them are ready are in wait to start production, and some of these application products started production. And we also work a lot with other clients on develop what we call custom advanced wafer level packaging technologies that are always based on our 3D RDL technology, and that to meet their current and next generation requirements in terms of performance and integration density for their products.
Can you give our viewers a sneak peek at what might be next for your company?
Yes, sure. Currently, we are seeing a lot of demand for our wafer level 3D packaging solutions, mainly for RF applications. The one like I cited before, even for IoT applications. Therefore, we are preparing on expanding our activity and most certainly our production capability. So we are working on fundraising and acquiring the required funds to install a 200 millimeter pilot line. So this line will be intended mainly for offering both advanced wafer level packaging services, and also to be able to integrate our 3D interactive passive devices. I haven't talked about this technology, but we have developed very performant, very small 3D integrated passive devices that we use for RF applications.
Well, you have a lot on your plate, and there's certainly a lot of opportunities for growth in the semiconductor industry right now. Thank you so much for sharing your insights with our viewers, and to the audience, thanks for tuning in to On the Flip Side. See you next time.